going to show you, right? And then double click here, 100, you can double click again, double click, right? You see, it's going to show you the base length, right? Or maybe if I double click here, similarly, this is the variable name. I can rename that one from here as well. I'll say here base, I'll say width. So while creating your dimensions, you can name it, apply it. And let me go to the, what do you call this, variables again. Right, you go to open up, you see base length and the base width. So either way you can do that, right? Either through this interface or in the other one. Now this one is what? 40. Remember, one length is 40, other one is 25 or something like this. If you can appropriately name this one, this is 40. You can, I would say, for example, left gap, for example, right? And then I will say here, it was the bottom gap, right? I'll say here the bottom gap. And then you can say here, I'll say here, for example, I can change, you can see it's automatically assigned this name. I'll say base, so for example, height, right? Now I have defined all the variables. Now I can use them at any time, right? If you want, I can take that one as reference and then adjust the other one. Or else you can define your user variables over here, right? Maybe you can say over here, I can define. I'll say, for example, I can say maximum length, right? What you should have. I'll say something like, say, 125 millimeters, because it says it's a distance. It says it's a distance. And we would say here, say, for example, the minimum length. Right? I'll say something like, say, for example, 75. It's also in millimeters, right? So if at any time, if you want to relate this one to the maximum length, I can say that is equal to maximum length, right? I'll say here maximum length, right? See whether if you enter what is happening, it's going to change it automatically. It's going to change it automatically. Now you can't change. Look at this lock sign disappeared, and then the background color from white to light gray shade changed. That indicates that I cannot change it. If you want to change it, you have to change the maximum length. Right? Or else you can even write some relationships. Right? You can write some relationships. You can say, for example, define this value. So you leave it up to you to change, but you can define the upper limit and the lower limit. Formula I would say less than or maybe greater than, something like this. That's also possible. We'll come to those complex scenarios later. Now I'm going to relate this one to the base length, right? I'll say here, this should be equal to, say, the base length. Now I'm going to use one of my own variables, dimension variable. Base length divided by, say, 3, 1/3, or maybe 2/3 of that one. I'll say 2 times length. How much is that? You can check this one. 83.33, right? You can try these things. Even decimal place accuracy will be a factor later. You see, that is how I change it. That is how I change it. So if I close this dialog box, now you see, if you double click here, 40 is still changeable in red color, right? 120 I cannot change. You see, that's in blue color. That indicates that you are what? Referring to these values through a formula or some sort of a relationship is there. If you want, you can even add some, what you call the sine, cosine things. Complete mathematical calculations can be done. Except for the very straightforward relationships like midpoint, equal, those things are freely available, called the geometric relationships. But here is the parametric relationships, where you can relate not only this one with anything else. This is within the part, and you can do it between parts as well. So you have the gear wheel and the shaft. So the gear wheel should go and sit on a particular step of the shaft. So these two diameters need to be meshed. So during a calculation, you realize that the shaft diameter is got updated, right? But at the same time, the gear wheel, the diameter, the whole diameter should also be updated. If you can remember these things, then of course you can do that one. But imagine with large number of components, you may not be able to do that. Or else you might sometimes update a wrong gear wheel. There are almost similar gear wheels, there are many. So the best thing is to relate them with formulas. So then when you update, you don't want actually to worry about that one, right? For that to happen, you have to be careful, because when you do it first time, do it correctly and test it, whether it's going to function or not. And after that, maintain that one. And if you want to write some relationship between parts, don't change the part name and also the location. You finish everything at once and then start defining the relations, means the two variables, right? Don't do it at once. But when you start doing that one, before you conclude, test it by changing some values, whether they really going to function, right? So that way you should be able to, manipulate most of the things. Now, you are worried about your calculations are not finished, right? And then there are many changes coming up in the future. That's usual. But anyway, you can reduce the amount of work that you're going to repeat, right? By creating models like this, where it responds to your updates quickly. And also, when you do the calculations, you can use some say software like even Excel, for example. It's a one-time effort, but you can use it any number of times. It's even possible to link Excel with Solid Edge. Right? I need to update myself before I teach you, but it is also possible, so that your Excel sheet is linked with Solid Edge as well. Now you don't have any worries after that. Right? You simply do the calculation. Now you finish the calculation, you find that something failing. So you come back and then see what options are available. You can change the material type. All what you need to do is sit and wait and look. Everything will be updated. If you can adjust those things, then it's nothing. I don't ask you to do everything, but it is possible. Right? It is possible. This is how you should handle things when you go to the industry. Otherwise, there's no point. If you use the same amount of time as the manual, conventional way, right? That's not acceptable. One-time effort is worth many times effort in the future. Right? And you can't remember also. You can even fully automate even the Excel sheet. You can even put some material data. You can even you don't want to go through and then type the values. You can simply select, like what you saw in Solid Edge. You can simply go and select, right? Any questions regarding the variables? Try out in a simple manner, right? Then you can learn. Try to relate. Don't go into the more complicated things, right? Don't go into the more complicated things. I will open this the variable dialog box again. Anything you want to ask, clarify? Okay, were you able to understand or follow this? And will you be able to apply this one, at least some of them, to your design work? If you feel lazy and then okay, you don't get this unnecessary trouble into your work, you try to complete everything like that. That's up to you, right? That's up to you. But this is how you learn things. Once you go to the industry, maybe you have to work under someone, and there will be many under your authority. So they are doing the design work, they are doing the modeling work in this old-fashioned way. You should be able to advise them, right? You should be able to advise them. Otherwise, let's say for example, you ask someone to complete work, you have only very limited time. Okay, you give him 2 days. You give him 2 days. Say within 2 days you need to give me the finalized model. But that person might tell you, sir, 2 days I can't do that. Maybe I need at least 3-4 days. If you know exactly, then you can ask him, no, you need only 2 days, not more than that. You are confident enough to tell him, no, you should only take 2 days. But if you have no idea, then you have to obey and wait. You take the responsibility, you take the burden of someone else, right? In the industry, you can't work like that. You can't work like that. Right? Now you feel the pain. I know that time is limited. Maybe you are already late, but anyway, time is limited. Right? Your pain is. I know that we have all gone through this effort. That is why I'm giving you these instructions and advice. Today we feel comfortable, very comfortable, because we know how to do all these things. But you don't know that. Right? But once you learn this one, you feel comfortable for the rest of your life. For the rest of your life. This is why we should even teach this one. Otherwise, I don't want to teach solid edge or something like this. I can ask the students by giving some tutorial and other things, do some modeling work. So this maybe you can demonstrate it, but not going into the details. Okay. So please ask if you have any questions. Please ask if you have any questions. I hope you can try these things. At least I can help. Right? And I don't mind even using some extra bit of time to, explain you out of this one, right? But if you feel that it is too much work because you don't have time, but anyway, at least few students can master this, right? Few students can master this so that you can share your knowledge with the other colleagues after. Right? I request some of students, I know that they are done already, and then they should be able to do that. So imagine now if you want to do some changes, nothing, right? Only the first time effort. Only the first time effort. Start simple. Add those complications later. Don't try to make the whole thing the big thing at once, right? No questions? No questions? Then I will see the other part. Even this is the shaft designer, right? As usual, right? You are not asking questions. Let's try to understand the basics or the fundamentals of assembly modeling. How you can assemble several parts together and then create an assembly. If you want to animate, you have to make sure that you start with the assemblies. Assemblies are put together using what we call relationships, right? Actually, to be exact, the parts are put together using relationships, and then you make it an assembly, right? Make it an assembly. The procedure associated with putting together assemblies is similar no matter which workflow is. There are different workflows. So for example, you can create the parts separately, assemble together, or you can start an assembly, create the parts inside. You can import some parts, right? Or you can take the first part in, the second part in, third party in, and then define the relationships. Right? It's still the same procedure what you are using. And parts and sub-assemblies for a bigger product, it's very convenient for you to, if you can divide them into sub-assembly. So you maintain the sub-assembly. So for example, you have a motor. You are not supposed to, model the inside of the motor. But let's say in case you are requested to even model parts inside the motor, then you can separate them. Motor assembly, right? The motor assembly. So you bring that sub-assembly into your main gearbox assembly, right? Or even the gearbox assembly, you can think of as another sub-assembly. So bringing them together, all different sub-assemblies, and then create a main assembly, right? Same sort of relationships that you have to define between two parts, or maybe between two part surfaces, or between two part references. You define different relationships. If you want to fix it, you define that way. If you want to leave some freedom for movement, flexibility, that also you can define. So this part finder, unlike in the part modeling interface, you can access very many what you call sort of different information, right? Even the what you call the relationships, anything added, links with external things, with variables, all these things you can see in the part finder. So these are some of the relationships available in the assembly interface: flash fit, mate, planar align, you see axial align, insert, connect, and then angle, tangent. You see even on the other side, the right hand side, you have gear, the match coordinate system, center plane, rigid, and then very important thing at the bottom, ground. Right? There are some other relationships as well. So these relationships you can use, and if you see the help file, you see you can access all these things. How do you place parts in the assembly? How do you insert component within the part? You can create cloning components, right? All these things are there. You can just try the most basic, and then when you have a requirement, then you can go and try, right? So this is how you're going to create a new assembly file, right? You create isometric or maybe metric or any other thing, the template that you want, and you go to the sub part list. There you have the first part, isometric assembly, right? Isometric assembly. The extension is ASM, right? Extension is ASM, right? And then if you create that one, then you're going to get a new part like this. Right? Nothing difference, right? You will see the almost similar interface, except some commands are changed in the ribbon, and also the references or the mates are different. So what you do, you can see you have two ways to insert a component or a sub-assembly. You either select insert component, means that component has to be created earlier, saved in some location, insert some standard parts. I still recommend you don't use that one for the time being. Later you can do that. Otherwise, it's going to be something like how do I say, the Basunas work, right? At the end, you can't be happy about this because I didn't create anything. I just collect some parts here and there, and then assemble it. So insert component, if you select this one, then there will be another dialog box coming up. Then you can access your what you call the hard disk, or if you are allowed, you can even go through the internet. It will show you all available all available what you call files. And then if you click on that top bar, training, title training over here, you can browse the hard disk. You can browse the hard disk and then look for your part files or the assembly files in different folders as well, different folders. You only need to select one from here, right? Or you only need to select one from here. And that will be automatically inserted. Okay, I'll show you all these things. That will be automatically inserted into your, what you call, assembly file, right? So let me close this. I don't want to save it. Maybe that's also, I will not save it. All right, I'll not save it. We'll see whether we can get some parts already. Say new, and then I'll go to, this is, remember, part 5 template. So I don't have a template created for the assembly file. So I open the standard templates. So I go to metric or ISO metric, then ISO metric assembly, and then I say okay. Right, so go to the pathfinder. Right now there's nothing much. Reference planes are there. Of course, you can show them always, right? Coordinate system is already there. You can see it's always there, right? All these things are. It says assembly name, assembly 8, right? Nothing else. And then I go and say insert component, right? Insert component. You can see over here some parts are there. Maybe I'll go to say computer. Maybe in this particular folder, I'll go to the folders, right? For example, this one. I hope there are some parts will be there. Say videos, say models. You see all these parts I can access. These are some of the files that I created for the demonstration work, right? Maybe I'll try to create some part like this. Maybe I don't know whether it is synchronous or not. Doesn't matter, right? So I'll just create this part. I'll just create, open this. Just click, or you can drag it and double click. It will be inserted and then placed over here. I see. That is the first part. That is the first part. If I select this, you see over here, what is this symbol? If you can remember, this is what you call the ground symbol. Can you remember in my slides I showed you these relationships? You see the last one? That is the ground thing, right? Means if you are familiar with what you call SolidWorks and don't want to compare, this is something like what? Fixed. Fixed means first part in any assembly that you insert into will become automatically fixed, right? Suppose I want to change this one, say with reference to the planes. You can see over here. Maybe it is done. Maybe I don't want to do this one over here. I want to bring this one maybe up to this surface. This surface should be aligned with that one, right? And other things may be okay or acceptable or not. So I need to remove that, what do you call this? I need to remove this. I need to remove that, what do you call the relationship over here. I can right click, say I can delete relationship, right? It's gone now. Or maybe before that, you see whether it is already there. Yeah, it's already there. I can try to drag component, right? I tried the same thing. You see, I can try to move, I can try to rotate, I can try to freeform move, I can drag as I wish. Maybe I'll try to drag this component. You see, I can't even select, right? If you go there and see whether options are available, locate grounded components, you can try all these things. See whether now I can do that. Because it is grounded, it says. Now the location will be changed. Location will be changed, right? If you cancel this, then you won't be able to do that again. You can't even select. You see now, you can't even select. You can put back, right? And then forward. Because you are assembling this, and then you can try to rotate. No, it's not possible. Why? Because it's already grounded. Unless you enable this, so that even the grounded components can be rotated. So let's say about this axis. So I should be able to rotate it, right? I should be able to rotate it in order to place the component, right? Place the component. Back is like this. Or maybe I'll undo this. It's in the original state right now. Then what I can do, maybe if I want to assemble it the way I want, then I delete this ground relationship first. Apply. Now I can try to drag this component. You see it's move, for example. Now I can select, right? And then I can move freely, whatever, wherever the direction that I want. Right now you see the original location is gone. Original location is gone. Go and select. Now it is in the floating stage. If you mount something onto this one, and when you move that, everything else will move. So that is the logic or the reason why Solid Edge or any software is going to fix the first part. Fix the first part in some appropriate places. But maybe I don't want to do that one. If I want to have it my own way, then I do it that way. Let's say now I want to make sure that this bottom reference is coincide with this one, or maybe even this one, right? I can try that one as well. So here I have the other relationships. You see here you have the flash fit. You read that one carefully. What do you mean by the flash fit? Right? Planar, align, axial align, and the connect. Maybe if I say, for example, mate, and then you can say align. You see here, right? The animation, align. Now if you go to mate, you see what's going to happen. Mate, this one, and the other option. You identify the difference? Align is the, if you have a surface normal, right? Normal detecting outwards. Align means the two normals will be in the same direction. Mate in the sense they are in the opposite direction. They are in the opposite direction. Right? You select the bottom surface of the blue color one, top surface of the ash color one. So they're going to put together. In the previous case, the front surface of the and with the front surface of the ash color one. Right? So let's try both. I'll try to first see the mate, for example. Then I'm going to select the bottom of this face, right? Selected, and then this surface. You see the direction is there. Now you see already here is already there. Right? You can even define some distance of that one. You see you here the distance. Just click or maybe select the simple button. Now it is fixed in one end. Right? Now I want to say align this one, or maybe mate this one with this also. Right? Let's say, how do I do that? Or maybe I'll say, okay, I will mate, right? Say, for example, this one, I'm going to select this face, right? And then I'm going to select this face, or else this face. You see, whether this side or that side is going to be the same thing, right? Now what is happening? Let's say what's going to happen. I selected mate option, but it's aligned. It's aligned, right? Can I reverse it? You go down and check whether element offset type, I can say flip. You see, I can say flip. Select this one, then say apply and check. It's okay now. Sometimes Solid Edge automatically decide. Right now I'll say align, for example. Let's say this face, I want to align with the back face. Now I select the align option. Maybe I select this one first, and maybe this one next. You see, now it is aligned. Now the component is in my own location. How do I center? We'll come to those things little later, right? That is there. That is your first part. You see the relationships over here. Right? If you select this part, now you'll be able to see, right? Maybe several of them, right? Several of them, right? If you see here, you'll be able to see several of them. These are relationships. You can see even the distances are over there. And even variable is defined for that one to define the distance. Right? Say suppose I want to change that one. Here it is 0. See whether I can change that one to some value. Right? Offset value here. If you say offset type, I'll say something like 10, see whether it is possible. It's moving. So I can define a certain distance away from that one. You see, that's also possible. That's also possible. So let me try to bring in the second component. I don't know whether I have some part over here. Let's try. Uh, I'm looking for some compatible part here. Okay, let's try this one. Right? Definitely the holes are separate. Right? Let's try this part. I just drag in and then place it. You see, it's now free to move. I just click, and then you can click on the select button. It is placed in a random position. Random position. Now, if you want to set these the holes that matches with this one, then you have to use the variable step and then manipulate that one. Now, maybe I can turn off the reference planes. Now you have to be very careful. The more and more parts you insert into the assembly is going to create more and more reference planes. Right? So you have to be very careful of identifying what is the right thing to select. Because everything will be named as front, maybe XY plane, YZ plane, or ZX plane, something like that. Right? So how do I do that? Now, for example, I select this mate option, select this face, and then go and select this face. You see, it's going to align that one in the bottom, right? Now this can freely move here and there, but this plane contact will always be there. So you see some other options are there. Axial align. You see the insert. For example, if you have a connect, you can say it need to be parallel. For example, the gear, for example, all these things can be there. Center plane, for example, you try all these things, right? You can say rigid, you can say ground if you want, and there are many things that you can see, right? I'd say align, for example, this is the align option. I select this one and then select that one. You see, it is aligned already. It's already aligned, right? Or you can say, for example, I'll remove that align function, right? I'll remove that align relationship. That is this one. I delete this one. Delete. Right? Now it is. Now I will say, for example, parallel. For example, right? I'll say this one. I'll say so. It depends on the placement. Right? Maybe I'll just define. Maybe you can use even these edges. Right? But what I want to show you is that maybe I can define the relationship and then define the offset, for example. Right? Offset, for example. I'll say offset is say 5 millimeters. You see, it is. Did I offset type fixed, floating? You can say even in a range. You can say fixed. Offset, okay, will be fine. You see over here. That is this. But why it is not going? When you say align, no. Okay, I'll undo this and do it again, right? Plane align, that is, right? That is plane align. So I will select this, undo this. I'll go to this option, right? And then select this one and select that one. I can flip. And now try to define the distance. If it is fixed already, there should be some parameters to check, right? Like in the previous case, we should be able to change, but I'll put it into float and then try to, when you say float, it's moving, right? It's moving. Right, when it's a fixed, it's a fixed. And then of course you can say even range, for example. Right? If you put on a range, for example, then it goes between these two values. So what does it mean when you try to drag this component, say move this component, it will move only in a certain distance only. There's something else is controlling this one. I should be able to move on to the other direction because there's no relationship, but maybe this side something is locking because we tried various options, right? Yeah, it's locked for some reason, right? It's not for some reason. Otherwise, what do you mean by the range is what do you call should be able to freely move between two values, between two values. Right. I'll clear out all these things, or maybe let's say I'm going to delete that what do you call the last relationship, and then I will do a different option that is called insert option. So axial align and also insert option. See whether I have only two holes, right? See whether I can do the insert option. One is here, the other one is here. Right? Insert means you insert a pin or bolt like thing into the assembly. See whether you have created that assembly, nothing yet. Then I will go into the axial alignment. So I select this one and then I select on that one. So that is possible. You see axial alignment. So insert means you are inserting a cylindrical item, right? Because this is not insert. You align the axial alignment. Now you can say maybe I can drag this component. Say for example, drag component, I can say rotate. If I select this one, when it is fixed, or maybe you can't rotate that one. This one you should rotate, right? Top one you can't rotate because it's already fixed. Say about this axis, now I can rotate, right? I can rotate this one. Or else maybe after doing so, maybe for some reason it happened like that. Then I can go and say, try to delete the planar line. And then you have even the parallel option. See whether now it's going to work like this. Maybe this one, or maybe say this edge, maybe parallel with that edge. You see, conflict with others and cannot be placed. Supposed to be like parallel, but anyway you are not allowed to do so because of the conflicting relationships. And you can try to say, for example, align them, planar lines. Say what is going to happen. This one with this, same thing is happening because it's locked by the other one. But there are many other options you can see here. Connect, say insert is already done. You see the you can try the angle, for example, right? Now say for example between this one and maybe that one, yet no complaints, you can see the angle 0. You can try, or maybe 25. See whether it is possible. I think something is wrong with the second part. It's not moving. There's no complaints, but it should be able to this one. Right? Show all dimensions in the lineages. So this is, what is this? No, that is the planar line. That is for the first one. Now, if it is successful, then it has to be placed over here. You see, rotation unlocked. This is this part. This rotation is there. Now it's not working. For some reason it's happened. Right? For some reason it's You can lock rotation and then you can unlock rotation. Now let's try to, say for example, now it is locked. Now it is locked. You see, this is unlocked. You should be able to actually drag and move. If once you locked, you can't do that. Maybe what I'm trying to refer, maybe not relevant also, right? Say angle between this one, you see, creating a relationship, and then I'll put, say, this one. Only thing is not going to change. I'll check this one. I want to check somewhere it's locking something. Okay, I will check that one and let you know. Okay, so basically now you can save this one as a what you call sub-assembly. I'll say this is sub-assembly. I'll say this is, for example, sub-assembly. In the same folder where you have this, okay, sub-assembly. Then I can close this and create a new file, new assembly file again. So go to the standard templates, metric. Now template could be different, doesn't matter, right? And then you go to the insert component. Say it's in the model, I said sub-assembly, right? Sub-assembly. You see here, sub-assembly, and then you can drag it and then place it over here, right? That is the sub-assembly. And then you can, this whole thing is usually recognized as sub-assembly, and inside that one you have some other parts, right? The moment you select this one, it's already fixed, it's already grounded, right? Now moving parts relative to each other is a different issue. Or else I can insert maybe another component. Let's say, for example, we have that plate push, plate button. Okay. So that's the other part. You inserted sub-assembly and also maybe another part like this. You have to do this one carefully. You have to do this one carefully. Identify in which order that you should bring the parts. And then if I turn on the reference planes and other things, you can see now there will be many, right? If you turn on all of these things, there will be many reference planes are there. Base, the reference planes, all these things can be activated at once, right? So if you say here, height and show, you can do all these things. Right? That might complicate your, what you call, the assembly procedure. The reason is that because now here you can't even see that one, the detail. This is only a pattern of that particular part. Coordinate system, right? References, and even here, right? All the details of individual parts can be accessed. Suppose I want to change this one, I can double click. You can see before, without saving, we can't update the things. There are many things that you need to learn on assemblies. So before the next lecture, I would like to see some of your parts, maybe the shafts, maybe some simple gear wheels, maybe some bearings, for example, right? You create them and then we can try to build up. I will show you how to build up all these things, and also we should know how to generate even 2D drawings. But that also takes some time, right? That also takes some time. Do you think it is too much work for you? You all are silent. Yes? Too much work for you? Yes, come on. Tell me. Only 56 students are there as usual. Maybe after 2 more weeks, it will come down to maybe 20. If you find it difficult, what shall we do? You don't get any of these experiences, right? You don't get any of these experiences. Now, once you start working in the real environment, then you will regret. We should have learned these things that day and the other day and like this. We are not, giving sort of punishment to all of you, but we want you to learn and become like a strong engineer. You will not, kind of not fail under very small situations. You will not, run away from your job, right? Or just change your job because of the stress. Right? Everything is like that. Everything is like that. It's the stress. Now you know that this the gas cylinder issue and everything. 2 of our staff members from the chemical department appointed into the committee, and one of them is the chairman. Can you imagine their pressure right now? Can you imagine their pressure? One thing that they can do is they can say, no, I can't do this. Then what will happen to your reputation and other things? Both of them are senior professors in the university, right? I can imagine. Now, they have never tested this. Maybe they were practiced this. Never faced a situation like this. Everything is new. The entire country is now waiting for their report. Right? Can you say that I don't know? Can you say that we have not learned these things? No. Right? You have to face the situation. Face the situation. Now it is the right time for you to do this. You know this is hard, but not stress like the other thing that I explained. Right? You are still in a comfortable mode. You can practice, you can fail, you can do whatever you want. And you are still young. You are still young, energetic. Right? Hope you all are not married and have at least 1 or 2 kids. I don't know, during this COVID season, some of you have got married. And then, of course, you have some additional work. Right? Try your hard. Don't fail. Try your hard. Don't fail. We are not failing you anyway. Fail means don't just, go away from this, run away from this. Difficult, we know that, but try your best. We will help you. We will help you as much as we can. Right? Otherwise, definitely you're going to regret all these things. Right? Okay, with that, I think I will stop today. So why I'm telling you all these things are because I learned all these things by myself. If I can do that, why don't you? You can definitely do that. Definitely do that. That is why I have the confidence. Only thing is that you are not giving an attempt. I will show you. I think you can see the participant list. There is one Mr. Piyadasa. Piyadasa, are you there? I saw him, right? He was there even when I was a student. He's already retired now. He can stay quite calm at home right now, but he's also learning. He's also learning. You see? You see, he's there. You can remember Mr. Vedas, right? I don't know whether you have seen him or not. Maybe during your engineering drawing class, probably you have met him. You see, there Vedas is there. Right? Maybe he has done a lot of practices during these weeks. He was there from the very first day. Right? Very first day. I think even some others are also there. even Jonathan Munil, they are also not young, right? If you say you can't, and if Vedasa says, yes, I did that one, what will happen? What will happen? You should, you can. Don't, I mean, go away, run away from this side. You can. We will support. Only thing, you are not asking questions. Right? You don't, waste time. That is the first thing. Don't waste time. Plan your time. How much time I spend on studying, calculations, modeling, and everything, so that every day you have set time allocated for something. Right? Otherwise, you keep on, doing one work, forgetting about everything else. And finally, you will, cool down with your Facebook, or maybe the Instagram or YouTube or whatever things, or maybe watching some movies. Well, that is so comfortable. That is so comfortable. Don't do that. You all can do this. I'm sure more than 100%. I'm sure you can do this. Only thing is you need to give some effort, right? Okay. With that, I think I will stop. Otherwise, I'm taking too much of your time. So please let me know if you have any questions. Right? Practice, and that is the only way to get through this one. Right. So I will